Welcome back. Continuing the lecture slide on section 4.5. Topic is symmetry. What happens if your function is even or odd? This is an interesting exercise. Integrals of symmetric functions. Suppose f is continuous on negative a to a. If f is even, that is f of negative x is f of x, then integral from negative a to a of fx dx is twice integral from 0 to a fx dx. What does that mean? Area of the curve, area under the curve of fx from negative a to a is twice area under the curve of fx from 0 to a. Why would that be? Look at an example. Here is an even function. Even means picture on the right is reflected picture on the left. So if I'm looking for area under the entire curve, negative a to a, then it's obviously going to be 2 times just the positive half, 0 to a. All right. So that's the idea for even function. What happens if you're an odd function? That is f of negative x is negative of fx. Then integral negative a to a fx dx is 0. How come? Well, odd means picture is above, gets reflected and reflected once more. Or think of it as 180-degree rotation, you get the same curve back, right? Well, the idea then is whatever part lies above is reflected down below on the other side. In other words, this area minus this area is what is area from negative a to a. Therefore, they cancel each other and you have the total area to be 0. All right. So that's from symmetry. So here are a few examples. So symmetry a to b fx dx can be expressed as area above the x-axis and below y-axis minus area below the below the axis and above the curve. Okay. So anyhow, this was about the even and odd. Let's look at an example. X to the power 6 plus 1. This is an even function because if I plug in negative x, I will still get the same expression back. So because it's even, negative 2 to 2 will be twice from 0 to 2. The rest is same. Okay, there is nothing new. It's just calculations. Here is an example, more interesting example of an odd function. When you replace x by negative x, for tan it comes out. But these guys, they don't. So only one negative survives. This is an odd function. If I try to find its integral, this is not an easy problem. In fact, I doubt I can even find the integration. But I don't have to. Because it is odd, negative 1 to 1, integral is 0. Okay? That's where this approach is very useful. Odd functions, negative number to the same positive value, integration is 0. So you might not be able to find the antiderivative and evaluate it at the endpoints. You don't have to. That's the point of odd functions. As long as you are symmetric, your odd function and the endpoints are symmetric, then the integration is 0. Okay. So next slides. So this completes the slides for section 4.5. Next videos on, I will be going over problems from the web work. Until then, bye.